Hello, so we're back, and this time we have kind of like a nice laptop to repair. This is a dynabook i5 10 Gen, still a decent laptop. Now let's check the customer email. The customer is a computer business, and what they are saying, dynabook which isn't taking a charge, and we fitted a new battery a few weeks ago. It might be one of them dodgy MOSFETs preventing the charge. Are you happy to take a look? Of course. Easy pizza or easy burger, whichever you prefer. Well, like people said, I think we had enough pizza. Maybe we can have some free burgers. Huh? What do you think? Let's plug a charger. Actually, let's test it. Pressing the power button, nothing happened. Let's plug a charger. I'm gonna try to address few questions from you guys regarding the laptop repair business. Let me try to find a plug for this one. And this is the plug. Yeah. One question is, why laptop repairs? Why did I choose laptop repairs? Let's plug a charger on this one. So plug in the charger, and it's taking like 400 milliamps. Then it's down to 100. Pressing the power button. And the laptop it is coming on. Check there. 800 milliamps. Doesn't look like it's charging. Waiting for the picture. Probably the moment you disconnect the battery, let's say you have a dead battery, then the BIOS it will get reset, like on this case. 1.6 amps, and the laptop is rebooting. It's starting again, and we have picture. Check that. I'm plugging the charger, and the laptop is still staying on. Okay, let me shut down the laptop. So the laptop is off. Plug in the charger. No, it's not charging. Check that. Nothing. We have like 100 milliamps. Yeah, that's not charging. And we have no charging sign here. Actually, we do have a charging sign. Check that, the orange light. But it's like 100 milliamps, so that's not fine. Good. Let's open the laptop quickly. Now, why laptop repairs? The question is, why not? You know, you are dealing with high technology stuff, electronics, you know. Nearly everyone has a laptop inside of their house. So yeah, it's, you know, kind of challenging and give you some level of satisfaction. Why I choose laptops repair is because I don't have that much space. So if I will have more space, I would choose even TV repairs. TVs can still be repaired, but you need space. Phone repair, I'm not doing phone repairs anymore, just because it's not much. Or let's say, in order to figure it out a fault, you have to put a lot of work for free. Not only work, but you know, willing to crack the boards, you know, just to see if you can fix it or not. For me, it's just, you know, it's too much risk, and you're not sure you can fix it. That's the thing. Basically, trying to be performant. If I have more than 50% chance to fix something, I will attempt to repair. Otherwise, I will not. Like on the last video, just because we seen that CPU getting hot, for me was less than 50% to even try like a BIOS, because people said on the chat, sorry, you could try a BIOS. Yeah, but I try to stick with my own rules. And the laptop is open. Yeah, that's a classic motherboard. On the video I made it like probably like 1 week ago with a repair business, and people said, yes, sorry, but I cannot really afford to pick up the jobs which I know I can fix them, like power issues and stuff. And for that, it's a simple fix. Yeah, you need more exposure. That means you need like a physical shop, or if you want to work from home like I do, you can do it. But you have to understand the challenge here, because if you check online, every shop is a repair shop, and 99%, at least here, they don't actually perform electronics repairs, like component level repairs. If you are lucky, you can find a shop which has a multimeter, but most of the shops they don't, and they are replacing screens, battery, charging ports. But basically, yeah, they are repair shops. So if you just list online, you go on the social media, you try to get some exposure, and you say repairing stuff, the people are not really impressed. So I will say my advice, yeah, try to show up your skills, yeah, try to do some content. And these days it's very easy. Basically, it's only one app, yeah, for recording, and everyone is using it's OBS Studio. Then, if you are like mic shy or you don't have to show your camera. Just imagine my video without a camera; it will make probably no difference. Even more easy, you can record the repair, then edit, then add the voice. So you can show some repairs, show actually to the customers, look with what I'm dealing. Actually, I do motherboard repairs. I will tell you a fact, yeah. I have here the worst social media setup because I don't want to deal with the customer locally. And because of that, I cannot have a Google profile. I had a Google business profile, and they banned me. They said, okay, if you don't deal locally with the customer cannot come and drop the jobs, and you cannot have a Google business account. Personal, my business is not advertised locally, and that's a very big disadvantage because you go and search online, and you have all the shops near to you, near to the customer actually. Okay, let's check what's wrong with this laptop. Now, doing a good job and make the customer happy, it will bring you some good reviews, and reviews matter. Okay, we did few Toshiba Dynabooks on the past. uh you know what is the problem already, right? You know that, Toshiba Dynabook has a common fault, and that's a MOSFET which is getting shorted. I'm working on some tutorials, some shortcut, because already we have a lot of content on this channel. Try to do some shortcut and concentrated content regarding the laptop repairs. They will be online soon. Let's have a look at the MOSFET on this motherboard. So this is the MOSFET next to the BQ chip, which is, I believe, shorted. I didn't check yet, yeah? But we're gonna check now. And the MOSFET is not shorted. Lol. Really? I mean, probably this is the first Dynabook. Yeah, this is the MOSFET. How this MOSFET is not shorted? No way. So actually the MOSFET is not shorted. Okay. Okay, not that one. This one is good. We have the comeback MOSFET, and it's good. This is the charging circuit of the battery. And here the MOSFETs are good. Lol. Okay, this is new. I didn't expect that. Then here we have the input circuit. The first MOSFET is good. The second MOSFET is good. Huh? Unexpected. Wait a second. This is new. So 19 volts, plug in the charger. Good, the charger is plugged. What you are checking next on a case like this, you are checking if you have channel N MOSFETs, you are checking the gate voltage, which has to be 25 volts. And it's like 4.7. Okay, that's not right. 4.7 volts. So the input voltage is 19.2. After the first MOSFET is 19.2. Wait, I have no voltage drop here. Huh? We have 14 volts. Okay, so those are channel P MOSFETs. Yeah, channel P. Okay, then it's fine. And the output is 19.2. Okay, so the input circuit is good. Then moving back to this MOSFET, which I said usually is shorted. Here we have 19.2. And here we have 19.2, which is good. And here we have 25 volts. Then we have this MOSFET, 19.2, 19.2, 19.2. Let me plug the battery. Okay, this is strange. And it's taking 700 milliamps. So now it's charging, or the laptop is coming on? No, it's charging. Wait, how this is possible? What is the battery voltage? 1 second. It's 6.7 and it's going up. Check that. You can see the voltage is going up. That's the current. That's the current with this laptop it will take to charge around 800 milliamps. Okay, then I'm confused. Why they stand the laptop as not charging? So what they are saying isn't taking a charge. Dodgy MOSFET preventing the charge, but the laptop it is charging fine. You can see it's taking charge. You think it can be the charging port? Let's have a look. No, I don't think it's the charging port. No, it's not the charging port. No. No, here is clean. So not sure what should I say regarding this job, because they said they replaced the battery. $120, which is the pre-charge current, then wait, it's not charging anymore? No way. It's not charging anymore. Check that, like 120 milliamps. Okay, so that's the fault. Actually, they are right, it's not charging. Battery voltage, 6.8, and it's going down. I can't believe it's going down. 7.2. Well, now it's charging, it's taking 800 milliamps. I don't understand. All I did is to check the voltage, and the voltage is going up. Let's try one more time. I think it's taking a while before it starts charging. That's what I think. I don't think it's anything faulty here. But let's see. Yeah, and the current is changing to 800. Yeah, it's taking a while, and that's okay, that's normal. So I'm not sure what should I say. Should I power up and try to charge when the laptop is on? Well, let's do it. Actually, it is a BIOS battery, so why the BIOS is getting reset if here we have a BIOS battery? Let me check the voltage on the BIOS battery. And the voltage is 0.5. You know, this can explain why they are thinking the battery is not charging. So this battery is dead. Anything we can do with this battery? I mean, I have, you remember last time, I have few people on the chat saying, sorry, not like few P, a battery from, you know, to buy like brand new battery, coin batteries. And I forgot to buy batteries. Yeah. That's what happened. Yeah, the laptop is still on. But for me, it's strange. I'll be honest with you. Why the laptop is getting reset if the battery is dead? Because the battery is not used when you have a working battery inside. So basically, if I'm powering up the laptop now, it should come on straight away. Pressing the power button. It is coming straight away. Okay, let me shut down the laptop. So I will unplug the battery. The battery is unplugged. The charger is unplugged. Plugging the charger back. Pressing the power button. And we have picture straight away. So the battery, it will not make any difference, the BIOS battery. You don't need a BIOS battery if this battery is good. But they replace the battery. So on the moment they replace the battery, then yeah, the BIOS got reset. So even if I plug the old BIOS battery, you have to understand the voltage is not used. Okay, let me shut down. I unplug the charger, plug in the charger back, pressing the power button, and the laptop is coming on straight away. So I mean, it's kind of pointless to replace the BIOS battery, even if it's dead. But we can try to charge the battery a little bit. Of course, it's taking no current. Let me raise the voltage to 6 volts. Yeah, no current, but it is taking power. Now let's check now. We have 2.7 volts, huh? What do you think? Proper good battery. If I'm charging the battery a little bit more, then we'll be fine. Yeah, yeah. So checking one more time, and the BIOS battery has 2.8 volts. Brand new. The people, they have a very wrong idea about the BIOS batteries, how they are working. And it is possible the laptop to die because of a BIOS battery. And I will say yes, it is. And that's the case where you are not using the laptop. Just to have a discharge battery is not enough. So you discharge the battery, you leave the laptop few months without connecting the charger. On that moment, the power management chip, it will disconnect the battery totally. So you'll have 0 volts here. When you have 0 volts here, the laptop, it will take power from the BIOS battery. If the BIOS battery is reaching the low possible level for the memory, yeah, because it's holding a memory, then let's say around 2 volts, 1.8 volts, under that kind of voltage, then the content of that memory can get corrupted. And that's usually inside of the EC chip. So the EC chip firmware is getting corrupted. You cannot power on the laptop anymore. So you have to basically disconnect the BIOS battery, reconnect the BIOS battery, and then it will work. Very unlikely this scenario, but it is possible. So we fix the BIOS battery. The main battery got a little bit of charge. Pressing the power button. No, actually, no. The main battery is still discharged. Connecting the charger. I need 19 volts for that. 19 volts. Pressing the power button. And the laptop is coming on, and you have picture straight away. Yeah? Good. So the laptop is off. We are waiting for the charging current, but this laptop is fully working. It's nothing what I can repair here. And the laptop is charging fine. Now, going back to the laptop repair business, it's not that hard how the people think, So many things, it's kind of like, hard. You have no idea what's going on here. And why this board is looking hard to be repaired is because you don't understand. This is like a map, yeah? So if you understand the map, everything is easy. So you just remove this, you remove this, you remove this, you remove this, and that's all what you can repair, yeah? So all what you can repair is related with the power, nothing with actually the digital communication or digital data. You can't even check that. So again, to have jobs which you can fix, you need definitely more exposure. Now have in mind what I'm doing, I'm sharing. So, for you, not only you are sharing different faults and different repairs with others using, let's say, YouTube or Facebook, but also you create a customer base, customer watch, then they are thinking, okay, this guy is good, so I can, give my laptop for repair. Now, if you have a lot of time, then definitely it's worth taking like any job if you have time. Here in the UK, the time it's very expensive, and to make a living from the repair, you really have to be, efficient. Now, regarding the other stuff, okay, so this is a map. I need a real map, like schematic. And wrongly, the people believe actually the schematic is actually to repair the device, and that's actually a very wrong idea. I did in industrial electronics on the past, so actually my first job was industrial electronics. We are speaking about CNC, big CNC machines, and big variable AC power supplies. When you have something to repair and it's meant to be repaired, you have a bunch of documentation, like signals everywhere you can check, and voltages everywhere, and the steps you have to do in order to fix a fault, and what to check, how to check, and all that kind of stuff. So a schematic, just only the schematic, is not for repair. That's why I'm not using schematic. You never see me like using schematic. The schematic is just to give you an idea, yeah, to give you an idea like how are the components there, what they are doing, some voltages you can check there, but that's all. So in the moment you understand the map, the schematic is not really useful. Can be useful for beginners, yeah, just to figure it out what the components on the board are doing. But if you move forward, you'll realize the schematic is not really useful. Actually, I seen a comment on yesterday. A gentleman, I found a comment here, which he replied to electronic repair business. Are they profitable? Still worth in 2025? You know the video. And you can spot on the chat people actually they are doing this in a professional way. So having in mind, I'm not gonna read it because it's a long comment. But anyway, having in mind, you have a professional guy fixing stuff, which is telling you 99% from the jobs he are fixing without the schematic. He is on a particular niche of the repair business. But on the beginning, the schematic is very helpful. I'm gonna break down the motherboards, what every component is doing and how you can figure it out, how they are interconnected together. The laptop is still charging. 800 milliamps is not much what we can do here. Let me connect the M2 drive back. I see on the past many comments, sorry, why connect the M2 drive with the battery inside and the charger, and the M2 drive doesn't have any power. You can check with the multimeter if the laptop is off, yeah? But if the laptop is off, doesn't mean the laptop is on sleep. If it's on sleep, the SSD it will have power. So the laptop has to be shut down manually, and on that point you will not have power on the M2 drive. Now let's power up this laptop again, and it's coming on straight away. And let's wait for the Windows to see the charging sign. It is loading the Windows. And the laptop is charging and the Windows is up and running. The laptop is turning off. The fan is still spinning. And we are getting 0.8. Again, this is pure charging current. The laptop is off. Current sensor, and the current is going up to 1 amp. You can see that? Yeah. So the charging current, it is controlled. Now, as I said regarding the laptop repairs, what I said on the last video, basically all what you need to understand this map. Then you need a good understanding of the Ohm law. And more the Ohm law, if you are playing with the power supply, you need the Kirchhoff, the first law and the second law. That's all what you need. And it's not about applying formula. We never calculate stuff. You calculate stuff when you are a designer. So we are not applying formula, but we understand how the relationship between the voltage, current, and resistance, and how the current is getting distributed on a circuit. And this, like Ohm law and Kirchhoff law, the first and the second one, apply to every electronic device you're gonna repair. It's not only about the laptops; it's about the phones, TVs, whatever you are going to fix. But before I end up the video, I will insist one more time, because I've seen the people issues and the people problems. Most likely, you need more exposure in order to get jobs you can fix, or jobs you can have like over 50% probability to fix it. And like I said, yeah, one more time, yeah, exposure comes with you sharing your work. So I'm gonna stop now. We'll say, like, subscribe if you like the video, and see you on the next one. Bye. Wait a second. We are back, yeah? We are like 1 minute later. Because I checked the voltage on the battery and the voltage seems to be low. And I said, you know what? Let me check if the board is not taking too much current. And if I check on the plus of the battery with the battery disconnected, it's taking like check that, yeah? Like kind of strange, right? The current is going up and down around 70, 80 milliamps, which is a lot for a laptop which is off. So I think here we have more problems. So what will happen now? I'm gonna bring the thermal camera. Well, let's try to figure it out why this laptop is taking power without the battery and charger. So the thermal camera, it's on. I'm gonna come with the power supply on the battery connector, which is here. And not sure, how can we see? And we have two chips which are on, check that. Huh? So I'm gonna plug the battery. So the battery is plugged. And let's see what we have there. So here we have 1.7 volts power supply, and here we have 2.6 volts. Hey, what is 2.6 volts? You ever seen something like that, 2.6 volts power supply? Wait a second, let me plug the charger. So the charger is plugged, and you can see the things are coming on, like the BQ chip. It's not charging, it's taking like 140 milliamps, but we're gonna see that coil getting hot soon. Yeah, so you can see now it's taking 800 milliamps, and what is getting hot is this coil. And not sure what is here. Here is a MOSFET. Okay, the high side MOSFET. Yeah. But these power supplies, this one is 5 volts now. So check here, it's 5 volts. Why now is 5 volts? And this one is 3.3. How? So you understand the power supplies, which this one I was getting like 1.8, you remember? And now it's 3.3. And this one I was getting 2.6, and now we are getting 5 volts. So how this is possible? They cannot be like both faulties. So I'm gonna unplug the charger. Unplug in the charger. Well, let's see what we are getting here. So this one we are getting 3.3. 1.7, check that, 1.7. So suddenly they start getting hot. So this one is 1.7 and this one is 2.6. Yeah, so here definitely it is an issue. The input voltage is 7.4. Not sure if the voltage is an issue here, but we can check that. This is a very rare fault. I never found this fault before. So not sure if this is an enable signal issue or something else. So I'm gonna raise the voltage. Yeah, I'm gonna raise the voltage to like 8 volts. That's all. So coming with current on the capacitor. And it's taking 1 amp and they are still going strong. Check there. Let me raise the current. 1.2 amps. I'm assuming I am pushing this current into the battery. But that's why I'm testing it this way, is just to understand if the voltage, it will make any difference. Because when I'm plugging the charger, the voltage is going up onto the battery, and I thought that can make a difference, but it's not. It's not the voltage. So most likely those power supplies are somehow enabled or the enable signal is dodgy, or maybe we should have a look at the EC chip. The EC chip is looking fine, check that. Well, I can't see any liquid damage. Yeah, nothing. So why did those power supplies are dodgy? Hmm? Basically, they are working like half working, which is a very dangerous situation. So one more time, just to understand the fault, yeah? Now it's charging, the charger is plugged in, everything is fine. Our coils, they have 3.3 and 5 volts. I'm plugging the charger. This coil has 3.3. It happens after a while. After like few seconds. Yeah, now we have 1.7 and we have 2.6. This is a very tricky fault. I think it's because of the enabled signal, but let me try to find it. Where we can find the enabled signal? Let's see a pin like this. So this pin has 3.5 volts. Probably it's not that one, then can be this one. This one, it's 1.1. I believe this is the enabled signal. So I'm gonna plug the charger. Plug in the charger, everything is going back to normal, and this one has 5 volts. And the enabled signal here is 3.2. Check that, you can see. So unplugging the charger. Let's wait. I'm gonna short the enable signal to ground. Yeah, so the power supplies are coming on a dodgy state. Shorting the signal, the enable signal to ground, and nothing happened. Maybe I'm not touching. Yeah, check that. Actually, the both are switching off. Check that. You can see that? So both power supplies are going off. You can see? Ha. Yeah. So both power supplies are off. You can see on the thermal camera. Removing this, that means the enable signal, and we can prove that. I'm gonna unplug the battery. The enable signal is connected together from the both power supplies. So we have this enable signal, this one with this pin, I'm assuming. Yeah, check that, 1 ohm. You can see on the screen. So the both are enabled by the same signal. So from where this signal is coming, I'm assuming it's from the EC chip, but we can check that. So basically I have no idea from where the enable signal is coming. Let me check this enable signal. It's coming from here and from here. Yeah. So we have a track which is going inside of the board. Of course, those are together. So you can see here is going inside of the board. So what is the solution? That's my question. What you will do in this case? You'll say, okay, so something is providing this enabled signal dodgy. Yeah, like 1 point something volts, which is enabled on a dodgy state, the power supplies. Well, no, really. This enabled signal can come out from a dodgy chip. So in order to figure it out, if it's a dodgy chip, power supply chip, or not, we can remove one resistor. Let's say this one. So we remove the resistor, and we'll see now what is happening. Let me cool down the board quickly. Good. Let's plug the battery and the charger. The charger is plugged, and now the laptop, it will not charge. Yeah, because we disabled the 3.31. Anyway, that's not a problem. But let's check the voltage here, and here we have 3.3. The 5 volts one is 0 volts because we disable it, but the enable signal is 3.2 volts. Unplugging the charger, we unplug the charger. The enable signal is still 3.2. Let's wait because it's happening after a while, and the enable signal is getting dropped to 1.1. Check on the screen. You can see? Yeah. So my question is, enable signal is coming from here, or is coming actually from the EC chip? Huh? Let's solder back that resistor. So the resistor is soldered back, and we don't have many options with this one, so we have to break the track. So here we have to break that track in order to separate the enable signal. And we did it. Yeah, the enable signal is not longer connected. So what I will do, I will plug the battery. With the battery plugged in, let's check the voltage on the enable, which is here, and it's 3.2. And on the enable signal, we have 0 volts. Okay, let me plug the charger. The charger is plugged in. Of course, we have no voltage on this power supply. And of course, it's not charging. It is possible this also is providing the LDO voltage. Zero, yeah. So that power supply is providing the LDO. But anyway, let's check the enable signal, 3.2. That means on this power supply from here we have 5 volts, you can see. So this power supply, it is enabled. So unplugging the charger. We unplug the charger, we still have 3.2 on the enable. Let's wait. And the enable is not changing. It's stable 3.2. Check that. You can see. Here you have 0 volts. And here you have 3.2, the enable signal. And now we have 1.1. Check that, we have 1.1. And here we have 3.2. Wait, what? 3.2, 3.2. Oh, basically when I'm shorting those two together, I have 1 volt. Check that, 1 volt. And yeah, you can see the power supplies are getting hot. Why this? Why when I'm enabling this power supply, the enabled signal is changing to 1 volt? Any idea? Let's do a test together. Yes, I'm gonna lower the voltage to 3.3. And I'm gonna enable that power supply with my power supply. Okay, so I'm coming with the enable signal here. And on the screen, no, I can't see the other chip getting hot. Check that. No. So if I have a different enable signal, the power supply is not going dodgy. This is complicated. It's it's not complicated, but it's you have to think a little bit. So one more time, yeah. That's how you enable the power supplies, by the way, yeah. So checking the output of this coil, we have 0 volts. But in the moment we are enabling this power supply, the output is 3.3. Check on the screen, you can see 3.3. But the enabled signal is 3.2. So one power supply, it's enabling the chip, but the enabled signal is stable. So the issue is not the enable is not this is some kind of design fault. And the issue here is, I believe the chips they have an influence each other, and I believe because of the missing resistor. So here we have a resistor on the serial mode with the enabled signal, but here we have nothing. Yeah, so here is no resistor. It is a place to place a resistor, but it's not. It's made a bridge from the chip pin to here. So no, of course, no one took that resistor out. Of course not. Even if let's say if you take the resistor out, which is meant to be there, you'll have the power supply, it will not be working. But here, the track is routed here. So what is the solution? Well, we proved this power supply is good and is not influencing the enable signal. This one, we proved is not influencing the enable signal. The only problem is when you connect the both chips to the same enable signal. So from my point of view, I believe a simple resistor, it will fix the problem. What do you think? That's how you fix a design issue. I'm gonna unplug the battery. Let's yeah, we have to solder from here. You see, that's how a design issue looks like. Yeah, this is a bug. Yeah, it's something which the manufacturer didn't think can happen. Nothing is faulty. No, nothing is faulty. No. And you're right. Yeah, hardware bugs are hard to be found. But this was an easy one. Okay, I think we are fine. Let's check the resistor from the other chip. So here we have a resistor of this is quite low. No, I'm not happy with that. No, I want a higher resistor. So I'm gonna grab a motherboard and let's try to find a proper calibrated resistor, right? Yeah. This one has like 10 kilo ohms. What do you think about 10 kilo ohms one? I think it's fine. 10 kilo ohms. Hmm? So let's grab this resistor. The resistor is out. And the resistor is soldered. So what do you think? It will work or not? That's my question. Hmm? I know there is a trend where actually you believe, everyone believes, the manufacturer is better compared with any repair guy. And that's very wrong. You have to understand they don't have time to test. They are designing, they are inputting, different components on a program. They are designing the stuff and without testing, without actually testing. So it's not like they manufacture the laptop and they leave it on like for 1 year. No, they are not doing that. No. So now the power supply with the charger plugged in. Here we have 3.3. So the enable is working fine. Here we have 5 volts. So that resistor is working great. The one we soldered. Unplugging the charger. Unplugging the charger. We still have 3.3 here. Nah, it's going off. Check that. 1.7 volts and the enable is 1.1. Do you think my resistor is shorted? Under? Let's check. So my resistor, no, it's not shorted. No. I can't believe I'm fixing manufactured bug designs or design bugs. Yeah, I'm looking for a capacitor. Okay, this is the last try to make this thing work, yeah? Otherwise, we are moving to a dodgy repair solution. So I'm gonna plug the charger. So we are trying with a capacitor from the ground here. And still they are still doing the same. Capacitor here, and no, nothing changed. Okay, I try to make it right. You seen that, right? Yeah. I try to make it right. Didn't work. So what will happen now? We're gonna deliver a dodgy repair. Yeah. I'm gonna unplug the battery. I'm gonna remove this resistor. No, actually I can't. I can't do it. No, no, I cannot remove that one. I can remove this one. Yeah, we don't need it. It's fine. So we remove the enable from this one. Good. So now plug in the battery. Plug in the battery and the 3.3 power supply. It's working as it should. Is delivering 3.3 at the output, right? Not 1.7. Ha! What is this? And enable signal is 1 volt. Huh. But we tested together and it was fine. So basically, when this power supply is enabled, which is always, yeah, always is 3.3 here, the enable signal is going dodgy. The solution, you won't like the solution. You won't like it. I'm gonna remove this resistor. Okay, so the resistor is removed. If that resistor is removed, plug in the battery back, we have we have 3.3 the enable signal. So this power supply, it will start. Okay, so um, let me solder a bridge there quickly. Why they use resistor here? It's very simple to add delays using a resistor and a capacitor. So we have 5 volts there. When we are plugging the battery, we do have 5 volts. Yeah. On this capacitor, probably we have LDO 5 volts. Now I know here is some feedback, but I don't want to take the power from here to enable the other one. I'm gonna take the power from the 5 volts coil. I'm gonna use 2 resistors to make like a divider. Enable signal doesn't have to be necessary like 3.3. Can be like 2.8. It will still be fine. So 20 kilo ohms. So we're gonna solder this from here to ground. Here. Perfect. Now let's grab the other resistor. So the 10 kilo ohms one is here. Good. Perfect. Okay. And now we can use a wire because that's the idea. A wire from here to the 5 volts power supply. So we're gonna enable the 3.3 from the 5 volts. Perfect. So what about now? It will blow up. Let's see. Plug in the battery. Heat. Let's see heat. No freaking way. No way. No, this is impossible. No, I don't believe that. Let me check. Nah, I don't believe that. So here we have 1.6 and here we have 2.3. Huh. Why? And here we have 1 volt. Wait, I think we have a bridge here. Why we have 1 volt here? Nah, must be a bridge here. Let me check. So from here to here, it's a bridge. It's a bridge here. Yeah, it's a bridge here. Yeah, probably it's gone now. So from here to here is not short. Good. So we have 1.3 volts. Okay, and the enable signal is 0.9. 1.3. And here we have 2 volts. So if this power supply is starting, the enable signal is going dodgy. Okay, that's fine. Okay, that was wrong. You know what I should use? I should use the LDO power supply. Yeah, it's my fault. Sorry. Yeah. So the LDO we have 3.3. So basically, if we are shorting this with this, we here, it's working. It's not getting hot anymore. Okay, it's my fault. Okay. So what I'm gonna do, I'm gonna remove this wire and connect the wire exactly here. If it's not working, I have another solution. Why I didn't use the LDO power supply from the beginning? Let's see now. So plug in the battery, and it's working fine. It's nothing is getting hot. You can see. Yeah. So if we are checking the voltage now, so checking the voltage on this coil, we have 3.3. So on this coil we have nothing. Wait, why we have no voltage on the 5 volts? Because the enable signal is 0. 19 volts, plug in the charger. And looks like it is charging, it's saying 120 milliamps. The 5 volts power supply is working, the 3.3 it's working, everything is working. Yeah, it's taking 800 milliamps. Unplugging the charger. So we unplug the charger and everything is normal. And when I'm saying normal, on the 5 volts we have 5 volts, on the 3.3 we have 3.3. But you see, none of the power supply is getting hot because they are working normally, not on a dodgy way. When they are working normally, they are very efficient. The 5 volts switched off, and I'm okay with that. Yeah? Good. Let's press the power button. Pressing the power button, the laptop it is coming on. Check there the blue light. And we have picture, check there. Yeah, the window started under thermal camera. Yeah, that one is more hotter because it's the 3.3, it's the big 3.3, which is probably used for the chipset. But if we are checking the voltage, yeah, we have 2 coils. But this coil has 5 volts, and this one 3.4. Yeah, which is fine. And yeah, we have the charging sign, everything is fine. Let me shut down the laptop. So shutting down the laptop, and the laptop is off. See the fan stop spinning, 800 milliamps. Let's check for any extra consumption. Yeah, so unplugging the charger. and everything is going off. You can see no heat from these power supplies. We fixed it, a dodgy way, but we fixed it. You have to admit it. I don't know why I didn't think from the beginning to use the LDO. So this power supply is 0, and I'm okay with that. We don't need 5 volts anyway. And this one is 3.3, you can see? Yeah. So even without the charger, we have no charger plugged in. If we are pressing the power button, and the laptop is coming on, it's working fine. Yeah, you're right. Probably this laptop doesn't work with sleep and charge anymore. But that's fine, you know, that's just a small downside. Because the 5 volts is not staying on anymore, but it's all good. We fixed it. Yeah. So now the battery is not getting discharged anymore, and the laptop is charging fine also. That's why they bought another battery, because probably this battery was getting discharged quickly based on the fact the power supply was were getting hot. Cool. It was a long video. I mean, check here. We have like 1 hour on 1 hour OBS. Yeah. Why that happened, or why this is happening, and I can't tell you why. Because nothing is making sense. You will say, okay, sorry, the current of the enable signal is not enough. No, it's not that. Because we separate the chips, we came with the power from the power supply, and we enabled the power supply, was working fine. Yeah, no, it's a different fault, different issue. Hardware bug, I don't know, hard to say. Because the enabled signals are connected together. Why the enabled signal get dropped? Some kind of loop somewhere. Because it's taking no current. We feel like, what, like 10 kilo ohms resistor first time. 10 kilo ohms resistor and we have no voltage drop. That's mean not a current issue on the enabled signal. Anyway, I would say thank you for watching. You know, like, subscribe if you like the video. And see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.